Okay, everybody, I won't be here today. I'm just making some video, so your teacher for today will go over with you. She will play for you, Lucy. Thank you, Mrs. Lucy, for serving for me. Okay, let's do question number 4. We was on 2.8, by the way. We was on 2.8. And remember the title was the uniqueness, uniqueness theorem, okay? The existence and uniqueness theorem. Okay, this is the chapter. You can go look at it. And I did lecture in class. So let's do some exercise. Let's do question number 4. Check here under your textbook. Go on, check it out, and try to do question number 4. And your textbook is right here. You can start doing question number 4. Okay. And the first question they ask you is about this one. They ask you about determine phi naught. Okay. So determine phi naught. So determine phi naught now, you have to, let's try to do question number 4. And question number 4 is y prime is equal to negative y minus 1, and you have the y naught. The y 0 is equal, the initial value is equal to 0. Okay, we have this one. Just make sure it's negative y minus 1. Okay, we have this one. So the first question was 8, and 8 is to find y and n, phi and n. Okay, so remember you have the formula, and I already proved it in class about the formula is phi n plus 1 is t is equal to, remember first, so first things you have to know is y is equal to phi t. Yt is equal to phi t. I got it? Yt is equal to phi t. That's the first things you have to understand and know. Yn t is equal to phi n t. Yn plus 1 phi t is equal to phi n phi t. This is called, remember the 2 point we did in class 2.7, method of successive is Euler theorem. Okay, it's a method of successive. It's the same thing. This is a solution, by the way. This is a solution, and the solution is just a phi. Okay, so okay, let's begin now. So we have this one now, and we have the theorem is phi naught plus integration from 0 to t. Why the 0 in t? Because you have the initial value here. You have the initial value here is, remember the initial value is x naught, and x naught here is this one. Got it? Okay, just make sure you know it. And the next one is phi naught, and the phi naught is equal to 0, and the 0 is this one. This is the phi naught. You have to know it. Okay? You have to know something. X naught here is equal to phi naught. It's just this one here. Got it? Okay, let's begin now, just to make sure you understand. So we have the integration from the demi variable now, the fs phi t, phi s, because we're using the demi variable, okay? But now remember here, since we start with n plus 1 here, then we will start with n. Got it? That's why we have to do n here, phi n. And then ds, because we're using the demi variable now. Okay. And remember, phi naught is equal to 0. Just like I told you right now, y is equal to 0. Is equal to 0. Why? Because just like I told you here is equal to 0 because of the initial value. Okay. Then we don't have to write down the whole thing. We just get rid of this one. So then our final, okay, by the way, if you start to n plus 1, you can also, it's arbitrary. You can also start to phi n t will be phi naught plus integration of 0 to t, and then you have f demi variable of phi n minus 1 now. Now you have n minus 1. See the difference here? It doesn't matter where we store. You can store to this one, end up here. You can store to n. If you store to n, then the demi variable of the image of the phi will be n minus 1. Okay? It's the range. Okay. Let's start then the first one. Since the textbook start with the first one, that's okay. It will be easy for you to understand. Okay, we have this one. So one thing also you have to know about here, again, about this one. Okay, you can write it down as y dy over dt, since it's t, right? Since it's t, that's okay. We can write down in form of t is equal to f ty, just like I told you. Okay, you see that this one is right here. You got it? It's just that function here. Okay, fs phi ns is nothing then negative phi n and s minus 1. That's it. You see this one? It's just this one. Got it? Just make sure you check it out. It's just this one. On the y, you have to substitute by phi n s. That's a demi variable. Okay, let's begin now. So phi n plus 1 t is equal to integration of 0 to t, and then you end up having negative phi n s minus 1, okay, ds. Okay, we have this one. So now we can integrate now. We can just substitute by this one and just integrate. So now, since, okay, the goal is this. I told you in class, always ask yourself, what's the goal? The goal is, always when you do the math stuff, just ask yourself, what's the goal? The goal is to found. So we have to found phi 0, phi 1, phi 2, phi 3, extra until you know the pattern. If you know the pattern, if you know how sequence work, then you can end up finding the general FNT. Sorry about the noise. I got a roommate who talked too much. Sorry about it. Okay. So we have this one now. Okay. So now we can get, we can found phi naught. Phi naught, we already found it because phi naught is just 0. We good. Okay. Phi naught is equal to 0. So now let's find phi 1. From this formula, we can find easily phi 1. Okay. Phi 1, you can see phi 1t is just integration 0t and extra. Just let me write it down. Phi 1t is equal to integration of 0 to t. Okay. And then minus phi naught s parenthesis minus 1 dt. But what do you know about phi naught is equal to 0? So then for phi 1t is equal to integration of 0t, 0 minus 1 ds. So then phi 1t is equal to integration of 0t and then minus 1t. Okay, minus 1 ts. So here you will have phi 1t is equal to integration of 0t negative ds. So then for I will have just t. Everybody got that one? Just negative t. So then for if you integrate this one, you will have a negative t. So then for phi 1t is equal to negative t. Okay, good. Now we got our second one. Again, always remember your goal. Your goal is this one. This was your goal, okay? Your goal is to find those. So we already have 2 of them. Let's find the third one. So now the third one from the formula f2t is equal to integration 0t fs. Remember, it's fs, and phi 1 here. Look at the formula. It's here. Here is the formula. Just substitute here by 1. Okay, that's what I did here. And then ds here, s ds. Okay, I know phi 1 is equal to negative t. What does it mean? Then phi 1s is equal to negative s. I can substitute here. So now I will have phi 2. Okay, I will have a phi 2 is equal to integration of 0 to t, and then I will have, where is the equation? Go back and check the equation. You see the equation? You see this equation? Replace it by, you have negative parenthesis negative s, okay, and then negative 1, and then ds. If you don't understand, let me know when I get back. It's integration of 0t, negative times negative is positive, so you have s minus 1 ds. So then for you end up having phi 2, okay, phi 2 is equal to, here is one half s square, and here is negative s, and make sure you go from 0 to t, okay, and then you have here, you can write down like that, it's okay. You can also write down like that. Either way will work, okay. At least like I told you last time, is 1 half s squared is negative s. This is a United States notation at university, okay. But others country, since I've been to different country, others country write down like that. Here, like that. This is United States notation, okay? Okay, you can choose either way, is fine. It's fine for me, okay? Since we are in your country, in US, just write it down like this. Okay, we have this one. So you can put the t inside. So you have phi t, phi 2, phi 2t is equal to 1 half t squared minus t, okay? So then we can have phi 2 is t is equal to negative t plus t squared over 2. Okay, we have our second one here, and the first one was this one. Second one, and the first one was here. So we got a 2 so far. So let's find the third one. Phi 3 t is equal to, now let me go fast since now you know, t, and then you have f s phi to the, what was the third one? Let me check the formula since I use negative phi. Yep, it's negative. With a general formula is here. Here you have 2s parenthesis ds, okay? And then you can just replace it. You have 0 to t, and remember the formula of phi 2 is negative, all right? Okay, just make sure you know. So you will have parenthesis negative this one, okay? Phi 2t s minus 1 and ds. So since phi 2 is right here, so we can just substitute here. You have integration 0t, and you have negative here. You have t minus t squared, okay, divided by 2, minus 1, and ds. It's s, not t, it's s. So here we will have 1 half t square, no, s square, and here you will have a negative s to the third, and here you have 2 times 2 times 3 is 6. You will have 6 here, okay? And then keep going, you will have a negative s, and make sure you put the 0 to t, and you end up having negative t, and then here the second one is positive t squared over 2 and negative t to the third over 6. Okay, good. You have this one, and this one is at phi 3. So phi 3, you have this one. This is your phi 3. Okay, this is your phi 3. Okay, so we have phi 1. Phi 1 t is, no, phi not t is equal to 0. Okay, phi 1 t is equal to negative t, and then phi 2t is equal to negative t plus t squared over 2. Negative t plus t squared over 2 over 2. T to the third, t is equal to negative t plus t squared over 2 minus 2 to the third divided by 6. So why I write down this one, sometimes you don't have to go to phi 4, phi 3, phi 4. As long as you see the pattern, again, as long as you see the pattern, so you can summarize it, okay? Okay, let's do this one now. So what you should realize is this. Look at this one carefully. Phi 0 t plus phi 1 t, that's the way you have to write it down, plus phi 2 t plus phi 3 t. It's a difficult one, by the way. This part is a little bit difficult, so you have to be very careful. And this one is 0 plus, let me put negative 1, no, negative t, okay? And the next one, oh, no, just put, look at here, by the way, look at here. I just want to show you something. You see the 0 is right here somewhere, okay? The next one is negative t. This one is phi 1, okay? The next one is add them up. If you add them up, you have phi 2, okay? If you add them up, all of them now, you have phi 3. That's mean phi 3 combine all of them, okay? So just let's check phi 3 directly. So if you look at phi 3, if you add them up, all of them is the phi 3, okay? If you look at phi 3, it's the sum of all of them, or from 0, phi 1, phi 2, okay? So now if we check here, we can tell, for example, phi 3 t, if you look at this one, you can tell we can have, it's just the part. The powering here is just, let's move here, negative 2 parentheses, okay? If you put the negative side inside, because a negative 1 square, if the power is odd, if the power is even, it's just t square, okay? You have t square here, you good. Then plus negative t, everything square, divided by 2. I didn't change anything now, okay? And here is, keep going, we will have a plus, and let's see, negative 3 to the third to the 6, okay? You keep going, and so on. Those are just phi n t, okay? Now, phi n t, you don't have to do 4 or 5. You can do it if you want. But as long as you know the way, you will keep repeating the same thing. So you have this one now. Okay, look at here. what we realize is this. 6, for example, here is our little bit problem here. What you should realize, the 6, if you look at the 3 factorial is 3 times 2 times 1 factorial, right? And 1 factorial just, and 0 factorial is just 1. 1 factorial is equal to 0 factorial is equal to 1, okay? So 3 factorial is equal to 2 times 3, which is 6. Then 3 factorial is just 6. We can substitute 6 by 3 factorial. You got it? So here we will have negative 1. This one is just a negative 1, parenthesis 1 factorial, plus negative t square 2 factorial, okay, plus negative 3, negative t to the third 3 factorial, and so on. And this one is just Vn, okay? I already write Vn, and so on. So now here. So if you look at here, just like I told you last time about the E, so I proved to you about, okay, I think I didn't prove it to you yet about the ET, right? I will prove it to you class. It's just about the neighborhood. So I will go over with you about the neighborhood in class. Please remind me. And the cos also, cos and sine, okay? ET, by definition, we done it in calculus 2. By definition is a sum of n going from 0, okay? Just make sure it's going from 0 to infinity. That's the definition. It's not n, it's infinity. And then you have negative 1, negative t to the, it's too early to do that, but it seems like it like that, okay? It looks like this. So you have phi n t is equal to, here you have a negative t, okay? Here you have negative t, make sure here is t negative. You have negative t here, divided by, you see the is 1, 2, 3, it keep increases. And you have to realize something also, something powerful. Here is power 1, you have 1 factorial. The power is 2, you have 2 factorial. The power is 3, you have 3 factorial. So then to add them up to sum, the sum will be, this one is just the sum of, it's just the segment of phi n t is equal to the sum of I or K or J, either way will work, okay? Let's call it K. Either way is fine, okay? K going from 0 to n because of here, okay? To n, and then you have a negative t to the k, and then you have a k factorial. Okay. If k is equal to 0, we have only 1, and there is no 1 here. Be careful. Be careful. Look at here. Look at here. So if you think about this one, sum of k is going from 0 to n. You have negative t, that's why I told you here is a harder one, divided by k factorial. If k is equal to 0, any number power 0 is equal to 1. Plus, if k equal to 1, you have negative t, okay? You have negative t. And you have 1 factorial, okay? If k is equal to 2 plus negative t, 2 and 2 factorial, plus if k is equal to 3, you have negative t, 3 and 3 factorial. Got it? And so on. Look at here. What's the difference now? What's the difference between here and here? You can tell the difference is only 1. The 1 is the difference because 1 does not belong here. There is no 1 here, okay? You have 1 here. Now you can do what we what you can do is to subtract both sides by 1. If you subtract both sides by 1, you will have sum of k going to 0 to n, negative t to the k, and divide by k factorial minus 1 is equal to negative t 1 to 1 factorial plus negative t everything square divided by 2 factorial plus negative t everything to the third and 3 factorial and so on. Got it? So now you can tell here you have exactly this one is right here. So therefore you can conclude now your phi n t is equal to the sum going from k is equal to 0 to n, okay, negative t k and divide by k factorial minus 1. That's it. That's all. That's the question they was asking you. Okay, you have that question. That's the 8. Go back. Look at here. That was your first question. 8 is to determine the phi n, okay, in the arbitrary value of n for all n. That's mean for all n. This means just for all n. It doesn't matter, just for all n. And n is a natural numbers. Okay, we got the first one. So the second one is to plug the phi n, whether it's converged to be converged. Okay, that question number B, I have to skip it because you just have to plug the numbers 1, 2, 3, 4. Okay, let me just show you something here. You have this one, and the B, you just have to do this. If k, let me think. That question is a base about the t. Okay, here is t. If t is equal to 0, okay, if t is equal to 0, so what do you have? Phi 0, what do you have? Okay, if t is equal to 1, found t phi 1 is equal to what? Extra, and you can graph. Okay, this is a easy question. You can just graph it. I don't have to do that. Let's do the much important one. This is basic. Let's do this one. So let's do this one. If I copy this one, I don't know if I can. Okay, let me copy this one here. Let me copy here. Okay, if I copy the question, okay, this one here. Let me copy this one. So if I copy this one, that's the question they ask. Okay, let's do this one. So they ask us this question. Okay, they ask us this question. C is to express the limit when n is going to infinity of phi to the x, okay, is equal to infinity in terms of elementary function. This is solve the initial value function. Okay, solve the initial value function. Okay, I got it. Okay, one thing you have to remember, what did I tell you? About the phi? Y t is equal to y phi t is equal to phi t. Remember that one, okay? Now, but here our case here, if you look at our case, we have phi to the nt, and phi to the nt is equal to y to the nt. Got it? It's this one. So now, if you look at here, that question will tell you, I done it with you, I remember. Here, read that question carefully. That's mean solve the given initial value function. We done it, right? The given value initial function mean you have y prime is equal to whatever fty, and this one is the initial value function, okay? Solve it mean to find phi t. That's the meaning, okay? That's the meaning. So now, let's go back. Also, let me point out something. mean, if you take the limit, that's the meaning, I think so. If you take the limit when n go to infinity of phi to the n, infinity, it's just, if you go here, if you look at here, if you take the limit, that's the mean you take the limit when n is approaching to infinity of y to the n t, right? And this one is just yt. And the yt is the solution. That's what they was asking for here. You have to read behind the line, okay? Here is this one. That's the question they're asking. Always read carefully. That's the question exactly they're asking. Okay, let me do it now. So you have this one. Let's take the limit when n is approaching to infinity of phi to the nt. Here is just the limit when n is going to infinity of. Where's the solution? We just got it. It's just a sum of k going to 0 to n. Negative t to the k of k factorial minus 1. Okay, you got this one here. Okay, we are here. So if you have to take that limit when n is approaching to infinity of this one, limit a constant is just a constant. We don't have to deal with that. The only one we have to deal here is just the 1. You still have the 1. It's good. Just as a constant. The one we have to deal is here. Now if you take the limit, if it's going to infinity, so here we will have then is equal to the limit when n is approaching to infinity of the sum k going to 0 to n, negative t to the k, and then k factorial minus 1. Okay, and then here you just have to n go to infinity, then here it will be infinity. And now we are dealing with the series, negative t, k, and then k factorial minus 1. Now, if you look at here, let me go back. Math is beautiful. I told you many times, but you cannot see it. Limit when n is approaching to infinity of phi to the nt. Okay, here. You have this one, right? So remember, I told you on calculus 3, you can write down phi to the exponential in form of the series. Exponential is equal to phi to the k is going to 0 infinity of negative x. Just x. Of x. Let me raise it here. Just x. X k to the k factorial. We done it in class. You can also write cos x. You can also write sin x. How did you found this one? You found this one. It's not a formula. I hate saying the formula, and I don't want you to memorize it. There is some way to find it. You can choose fx is equal to x, and you can choose a neighborhood, any neighborhood around 0. Okay, you have a 0. Any neighborhood around 0. Okay, here is a neighborhood about 0. If you take the derivative, you still have phi x. Second derivative, same thing. Third derivative, same thing. Whatever, until you reach whatever infinity. Okay, the derivative will be always the same. So f0, you will have 1. You will have also f prime of 0 is equal to f second prime of 0. It will be always the same until you reach infinity. You got it? Now, since we are dealing with the neighborhood of 0 means close to 0. So now we will end up having fx. Fx will be, which is ex, is equal to f0. F0 is 1. Okay, f0 is 1. Okay, minus plus f0 prime of x plus now I have to use t because our solution was t. Let me use t here. Okay, that's fine. Let me use t. Here is t. Let me use x. That's okay. I will just substitute. Here is f second prime of 0, because we are dealing with around the neighborhood of 0. X squared 2 factorial and plus f third prime of 0, x 3 factorial, and so on, so on. You got it? So now here, since all this is just equal to 1, so we have 1 plus x squared, or let me call it now t, ft. That's okay, it's et. You have this one, you have t, and you have here 2 factorial, and so, and t to the third 3 factorial, okay, and so on. So if you look at here, it's just e negative t. Now if you replace it, you will have, if you move the negative side to negative 1 both sides, inside you have negative t parenthesis plus negative t square divided by 2 factorial, and then plus negative t to the third and 3 factorial, and so on. So if you look at here, it's the same thing we get this one here. Let me make it small. Okay, you see this one? The one we just got here is the same thing we got here. This one here, same thing. Because it won't stop, it will go to infinity, okay? It's the same thing we got here. So now we can conclude now. We can conclude easily now. So then here, our solution now, limit when k, no, it's k, right? It's k is approaching to infinity. Oh, the question was when n is approaching to infinity. Okay, that's fine. Is n is approaching to infinity now, of phi to the n t is equal to, if you look at this one, it's just the limit, it's just the sum series k going to 0 to infinity, okay? And here you have negative t to the k divided by k factorial minus 1. And here now we can conclude this one is just e negative t minus 1, because it's the same thing from here. Same thing here, this one. The whole this is just this one. And this one is equal to e negative t minus 1. And we got this one. So now, if you look at here, let me erase it here so you can see. Okay, I got this one. So this one is just, if you take the limit, it's just a phi t. And phi t is equal to yt. That's why they say is a solution of the initial value solution. It's the initial value solution. See, the initial value solution is phi t, is yt, and yt now is right here. That's what we end up now. This is C. Okay. That's it. If you have any question, let me know. Okay. Take your time and check it out and review it. I know it's a long process, but there is some part is very, very, very important. Please take your time and look at it. Okay. Okay. Since I do want to, you can do the rest. I'm quite sure you can do the rest. Let me do more. Let me do number, maybe number 7 or number 8 should be good for you. Just let me, maybe this one or this one. Now, I just want to show you how can you use lumber, because those, if they ask you to converge, because that one is different, okay? That one is different. That one, they ask you first this one, okay? And then they ask you to converge. So we didn't do that. We didn't do this one yet, okay? I just want to point out something about the convergence. That's why I use those. You can use this one or this one. It doesn't matter as long as you understand the process, fine. Okay, let's do then question number 8. That's okay. Let me copy question number 8. Let me copy the whole thing so you can That's it. And then we can go from there. If you have time, we can do the next. Okay. Problem number 8. Let's do problem number 8. Hopefully we will have time. Okay. Problem number 8, you have this one. Okay, you have this one, problem number 8. Let's do problem number 8. Problem number 8, you have this one. And problem number 8 is, problem number 8, you have y prime is equal to t square y minus 1, and you have y0 is equal to 0. Okay? Okay, you have this one. So the first question was here. That's the first question here. The first question is to determine the same thing, phi naught, and then observe the linear and converge. Okay, if it's converge or not. So let's determine this one. By the way, to determine phi naught, phi x is a harder one. You have to be very careful, okay? Just take your time and look at it. Okay, let's do the same process. Since we have phi naught here, you can tell, just like I told you, is equal to 0, and x naught is equal to, or t naught, since they use t naught is equal to 0, okay? So the same process, the same formula, we have phi n plus 1, t is equal to phi naught plus integration of 0 to t, since we use t of f of s, use the demi variable x phi n plus s, and then you have ds, okay? So this one is equal to 0, so say is equal to 0, and then we can find phi 1 t is equal to integration of 0 to t, and then you have f s phi naught everything to the t to the s. And then here, if you look at here, you have 0 to t, and then here you have a substitute from here, you have the t will be s times s square, and then you have a phi naught 0, and then minus 1, everything ds. Got it? Okay, if you don't understand, please take a look at it, okay? I use this one. Everybody got it? If not, please let me know. Oh, sorry about it. I just realized this one is t. I wrote 1. Okay? This one is t and I wrote 1. Sorry about it. Let me change it. It's t, not 1. It's t. So then here will be s. Here is s. Okay? Here is s. So now I got this one. Now let's take the integration. The integration for this one, so here y naught is equal to 0. So then I will have negative t and s and ds. So here then will be negative 1/2 s square and go from 0 to t. So then for phi 1 t is equal to negative t square over 2. Good. So now here is my first one. It's my phi 1. Okay, phi 1 is here. And remember phi 0 t is equal to 0. Okay. Now let's check the next one. The next one is phi 2. The next one is phi 2t is equal to phi naught plus integration of 0 to t, and you have fst phi 1t. And then ds, make sure it's s. So here you have integration of 0 to t, because this one is already 0 because of the initial value. So here now the equation was y prime is equal to t square y minus t. Okay, you have y prime is equal to t square y minus t. Okay, you have the equation. So then for we can set as this one be s square, and then you have phi 1 and phi 1 s, and then minus s. Okay, That was the equation. And here you have integration 0 to t, and then you have, let me see, phi t is equal to this one. And phi t is equal to s squared and parentheses and negative s squared over 2 parentheses, and you have negative s, everything ds. Okay, here you will have integration of negative integration of 0 to t, okay, and then you have s to the 4 over 2 ds, and then minus integration of s ds 0 to t. So if you look at here, you can tell if you take the square root, you will have a negative 1 over 10. 1 over 10 of s to the 5th. And then here you have a negative 1/2 s to the s square. Okay? And here you have 0 to t. So therefore you have a negative t to the 5th 10. And then here you have a negative s squared over 2. Okay? And then you have, no, t. You have t here. Okay? Yep, you have this one. Hopefully everybody get this one. At the same time, you can try it. Okay? So when I say, okay, let's do this, you can pause it and try it just for 5 minutes. Just 5 minutes. Try it just 5 minutes. Just try it one. Phi 1. If you reach Phi 1, so then you can play the video. Okay? So now I'm here. Or you can just keep going. You can just keep the video going, please. Because it's too long. It may take the whole class. It's fine. And I like it like that. So you keep you busy. So you have this one. Okay? You have this one. Okay. Now you can still, you have phi 2. Here is phi 2 is equal to this one. You can still not find the exact. You can keep going. Phi 3t. Phi 3t, the same thing. You can just 0 to t, and you have fs, and you have phi 2s. Remember the equation was y is equal to t squared y minus t. That's the equation. So here you can write down t, and then is s squared y. Now s squared and phi 2s, and then minus s and ds. So you have this one, and here is integration of 0 to t, and here is s squared, and phi 2, if you look at phi 2 is this one, okay? Phi 2 is right here. You can replace it by phi 2 is negative s to the 5th 10 minus s squared over 10 over 2 parentheses, and you have a negative s, and then here bracket and ds. Okay, so I know it's long, but it's powerful. And here you have if you move the 5th, the s squared inside with the 5th square, it will be 10. You can start with the low one, that's okay. Let's start with the low one, 0 to t, and you have a low, like a small power, negative s squared, and then the next one you have negative s to the 4 divided by 2, okay? And the next one will be negative s to the 7 over 10. So you have this one, okay? So it's 7 plus, just me make sure I got it right, 7 over 2, and you have s here, and you have this one. Okay, it's good. I think so. It's fine. So you have this one, and this one you have to take the integration. So now if you take the integration here, you have negative s squared over 2, and negative here it will be 5, it will be 10, s to the 5th over 10 minus, and here will be 8. 8 is 80. 8 is 80, right? It's 1 over 8. 1 over 80. and here is s to the 8. Okay, you have this one. And make sure it's from 0 to t. And here now you have your phi 3. You have your phi 3t is equal to negative t squared over 2, okay, over 2, minus t to the 5th over 10, minus t to the 8th over AD. Okay, you have this one. Okay. So now can we determine something here? You can check. You can still check. Let me check, or we can go to the next. I know the next will be too long. I shouldn't pick that one. It's a little bit longer, but we can still see if we can find something. So let's check the power first. So if you look at the power, let me get this one here. Let's check to here. Let's check here. So here is 2, because here, look at here. Here is 2, right? Here is 10. Here is 80. Because the power is fine. The power is fine. The power is easy to find. Because if you look at the power, you have 2 here, and you have 5, and you have, look at here. Let's look at the power first. If you look at the power, you have 2. The second one, you have 5. The third one, you have 8. If you look at the power, you can think about, because 5 is 2 times 2 plus 1, right? Or look at like 5 is 3 times 2 minus 1. 3 times 2 is 6. 6 minus 1 is 5. Okay? Okay. Look at the power here. 5 is 3 times 2 minus 1. 2 is 2 times 3 times minus 1. What I should get here? 3 times 1. Yep, it's good. 8 is 3 times 3 minus 1. 3 times 3, 9, 9. Yep, I got it. Okay, let me show you here. Let me show you about the power. The power, just by look at the power, just the power, 2, 5. You have 2, 5, and 8. That's why I told you here is a difficult one. You have to be very careful. Look at the power. Look at the 2, for example. The 2, you have 3 times 1 minus 1. Okay? The second one, you have 3 times 2 minus 1. The third one, you have 3 times 3 minus 1. Now, check here. I will have 1, 2, 3. That's all I want. And here it will be the same, and here it will be the same. And then I can conclude here. I can conclude about the power. The power then should be 3k minus 1. I can do that. That's the way you have to check. You can check the power. Always check the power and check the bottom one, the denominator. Okay? Good. So I can conclude, my conclusion will be the power T should be 3k minus 1. I can conclude that. So now I have to care about this one. To care about this one, the first one I got a 2, 10, 80. Look at here. I got 2, 10, 80. And remember, the power have to be, sometimes it's not always, have to be close to the, have to be the similar. You have to include on the bottom, on the denominator. Always try to create something, it will be included. That's the harder one, by the way. And this one make you smart, make you, it's just powerful here. You have to think a lot here, okay? So here I got this one. So the bottom one now, I can check. I know 5 and 8. Okay, the bottom one, check here the bottom one. The bottom one is 2 times 1. 2 times 1 is 5, okay? So the second one, I got a 2, 10, I got 2 times 5. Because, okay, let me explain to you something. See, the way you have to find this one, the pattern, is to think about the power. you have to make sure you include the power here. Okay, you have to make sure to express 10 in term of 5, express 2 in term of 2. That's why I say 2 times 1. You have to express 10 in term of 5. That's why 10 is equal to 2 times 5. Got it? And you have to express 80 in term of 8. Yes. Okay, let's do 80 in term of 8. Okay, 80 in term of 8. Okay, let's do this. I know 80 is equal to, first of all, write down 8 times something. Okay, 8 times 10. 8 times 10 is equal to 80. Okay, 8 times 10 is 80. So I know also 10 is 2 times 5. 2 times 5 times 8. Isn't it? Okay, let me change it to, what about the factorial? The factorial doesn't work. 2 times 8. I think will work. Okay, that one is good. I think that one is good. Okay, 2 times 5 times 8. Look at here. Look at here, for example. You see the 2? I have it here. You see the 2 times 5? I have it here. And I have times 8. So on, even you keep going. Okay? Now I can tell here, I can tell easily. So here, the 2, I keep going. I can tell here, let me change the color. I can change it to, 2. Okay, 2 is equal to 3 times minus 1 times 1 minus 1, and then parentheses times 1. Right? From here. I am proving from here. Okay, got it? Okay, the next one is 10. 10 is equal to, let me check, is 2 times, and 2 is this one. Okay, the next one is this one. I can write down 3 times 1 minus 1 times 5. Okay, and then the next one is 8, and this one is just 3 times 1 minus 1 times 5 times 8. Okay, let me, yes, and okay, I think I get it. Let me see. Here you have 8. Phi 3 t is equal to negative t 3 times 1 minus 1 divided by 3 times 1 minus 1, just 2. Just do 2. Just do 2. 2 for now. Okay, minus t times 3 times 2 minus 1 divided by 2 times 5. And here I will have okay, let me change the top. The top one here, I have 2, I have 5, and minus t to the 8, and I have 10 times 10 is 2 times 5. Okay, 2 times 5 times 8, minus, and so on. Okay, now I will I can change it now. I can change it to, let's see, here is 2, here is 5, and keep going, so on. So I can change it to, okay, I think you can do 2 times 2, 2 times 3, 5 times 3. Okay, I think it's fine. So you can write down t to the 3 times 1 minus 1. This is good. Divide by, because here, bear with me. Look at here, the 2 is right here, the 2 is right here, the 5 is right here, the 5 is right here. That's all I need. That's the way you have to construct yours. So I have this one, and this one is just 2 times, no, 3 is 3 times 1 minus 1. The next one is t is equal to, I think it's 5. 5 is equal to, what's the 5 I get? Okay, 3 times 2 minus 1 divided by, here was 2 times 5. And 2 times 5 is just 3 times 2 minus 1. Okay. Minus d8. And 8 is 3 times 3. Let me write it down here. Is 3 times 3 minus 1 divided by 3 times 3 minus 1. Oh, here 3 times 3 is 6. 6 minus 1 is 5. Make sure you write down times 2. Times 2. Okay. Here is times 10. Times 2. 2 times 5. Okay. 2 times 5. Here is 2 times 5. 2 times 5. Here is 2. Here is 2 times 5. Okay, I got it. Okay, you see here? Here, okay, here is 1 times. Here is 2 times. Here is 2 times 5. You see, it will keep increases. Then we can write down 2 times 5 and times 8 and times and so on, because we stop at 8. And if you look at here, the part is 3i minus 1. And times 3i minus 1 all the time. See, 3i's minus 1 here. 3i's minus 1. 3i's minus 1. You got it? Okay. Yes, you're right. Okay, here we can write down our, now we found the pattern. So we can write down our final solution, phi and t. That's the harder one, by the way. I spent too much time just to find it. That's the way you have to figure out. Is a sum of k going from, okay, I think I start from 1. Here, I start from 1. 1, 2, 3. You got it? K start from 1. K start from 1 to n. Okay? K start from 1 to n. Okay, now let's put the parentheses. Negative, and just like I told you, here is 3 times, so you can write down like this here, just like here, this one. Okay, you can write down like this. Is t to the 3k minus 1. Got it? And then divide by, anytime you move, you start with 2, just like I told you here, you start with 2. Okay, and if you move to the next one, you will have 5. 2 is still here, right? And if you move to the next one, you will have 8. And you end up, and if you look at the 8, you will also end up having 3 times. Look at here, 3 times 1 minus 1. 3 times minus 2. You see, keep increases minus 1. 3 times 3 minus 1. So therefore, we can just keep the 2 times 5 times 8 and times and so on. Okay? And so on. But since we stop to n, so we have to write down something. We cannot keep going with the a and n. We have, and it will be 3 times k minus 1. Okay, that's it. That's the sequence. It's hard, but it's beautiful. So phi n t is just equal to the sum from k going from 1 to n of negative t to the 3k minus 1 divided by 2 times 5 times 8 times extra 3 times k minus 1. And that's it. This was our first question on here. on here. So now the next question is this. The next question is plug F. Okay, plug in, we don't do that. So my concern is this one, to be convergence. To be convergence what? Let's find where is converged. Observe whether the, okay, let's check if it's converged. This is a question D, B. So the B asks you if it's converged. So when they ask you if it's converged, you have to check the original one, okay? You have to check the original one. So the original one was what? Look at this one. Look at here. You have the original one here. This one is this one. So you have to, okay, remember Alambert theorem. You call it quotient rule. Quotient rule is an plus 1 divided by an, and you have the limit when n is going to infinity of absolute value of this one. Now, just to recap, if this one is if you have a number like r is equal to r, if r is less than 1, then it's converge. You got it? I know I done it on calculus too. Okay, if n is going to infinity, if r is equal to is less than 1, then it's converge. If it's greater than 1, it's diverge. If it's equal to 1, then it's inconclusive. Okay, let's do it. So here we can set as an, for example, we can set as an is equal to, oh, here we can use an, we can use a k, because we use here k. A k is equal to this one, to the inside one, only here. That's the 8k. Be careful here, be careful. This is ak. Got it? So ak is equal to negative of tk, 3k minus 1 divided by 2 times 5 times 8 times whatever, and keep going, 3k minus 1. Use it, and then keep going from there. So here you will have a limit now. Limit. If k is going to infinity, that was the question, of ak plus 1 divided by ak, absolute value is equal to what? Limit of k is going to infinity of absolute value of negative t3 parenthesis k plus 1 minus 1 divided by, and you have here 2 times 5 times 8 times extra, and you have 3 parentheses k plus 1 minus 1, okay? And divide everything by negative t to the 3k minus 1 divided by 2 times 5 times 8 times whatever, and then times 3k minus 1. Okay, let's do this one. So here you will have is equal to the limit when k is approaching to infinity of this one. So here you will have, if you move the 3 inside, okay, if you move the 3 inside, what do you get? T to the 3k, and that 3 to the tk will cancel out. Yes, they will cancel out. So here you will have only, and 3 negative 3 and 3 negative 3 also will cancel out. So the only remainder you will have is this one. Look at here. Okay, let me point out here. If you multiply here by 3 t to the 3k, you will have 3 to the 3k. With the 3 to the 3k will cancel out. Okay? Now, 3 t to the negative 3 because of this one, it will cancel out with this one. No, it won't cancel out with this one. No, never mind. T to the negative t to the negative 1, it will cancel out with t to the negative 1 here. It will cancel out. Got it? and this one also will cancel out. So the only remainder you will have is t to the 3. That's all. You got it? I do it directly, but that's the only remainder you will get. Let me write down here so far. 3 to the 3. You got this one. So the next one now, let me check. The next one, you can cancel out also the numbers. All those numbers you will cancel out, except from here. So if you look at here, what do we get here? So if you look at here, 3k minus 3 plus 3, okay? And if you divide it by, no, this one, you flip it, it will be on the top, okay? This one will be on the top. So if you divide it, you will have a 3k minus 1. So let me see if something will cancel out. So this one, you will have a negative 1. Okay, here you have cancel out here. And here you will have, okay, I have to write down this one just to make sure. Okay, let me write down everything. So if you flip it, the negative sign will cancel out. If you flip this one, you will have 2 times 5 times 8 times extra, and you have 3k minus 1 on the top. And divided by here. Here you will have 2 times 5 times 8 times extra. If you move, if you distribute here, let's distribute here. If you distribute here, you will have, if you distribute here, you have 3k minus 3, no, plus 3 minus 1. You have 3k plus 2. Only 3k plus 2 here. Got it? So you will have that 3k plus 2, 3k plus 2. Okay. So what do we get here? 3k plus 2 and 3k minus 1. So we will cancel, it will cancel out then. 3k minus 3 and 3k minus 1. Okay, I got it. Okay, look at here. Let me tell you some things here. I think here it does make sense, because here, okay, let me break it down here. Bear with me. You have 2 times 5 times 8, and you have 3k minus 1, and then divided by 2 times 5 times 8 times 3k plus 3. Bear with me here. Here you will have 2 times 5 times 8 times and then you have 3k minus 1. Got it? So now you have 2 times 5 times 8 Here you will have 3k plus, oh, be careful. Before we reach 3k, what do we get? 3k plus 2. Before we reach 3k plus 2, 3k plus 1. Before we reach 3k plus, okay, let me break it down here. You have 3k minus 1, parenthesis, the next one will be times 3k, and the next one will be 3k minus 1, now plus 1. We increases, right? And the next one will be plus 1. And the next one will be 3k plus 2, and the next one will be 3k plus 3. Okay, we got this one. So then this one we cancel out, and we end up only having this one. Okay, so everything here, this one we cancel out. Okay, everything we cancel out except those. Here is 2, then it's here. It's only here. Okay, it will be only here. So here we will get, so what we should get is this. We will get the limit, then is equal to the limit when k is approaching to infinity of t to the third divided by 3 to the k times 3k plus 1 times, I think it was 3k plus 2. That's it. Okay, you can tell this one will go to 0. Why? Because k does not depend to t. So we can even move the t outside. It's only the k. Then this one is equal to 0. Therefore, we can conclude here the limit when k is approaching to infinity of ak plus 1 divided by ak, absolute value is equal to 0. So then we can conclude, I told you here about the ratio test, is just a number. If it's less than 1, then it's converge. Okay. Therefore, by a Lambert theorem, then we can conclude. What's the question? This is series or yeah? Then we can observe whether the okay, it's a series because it's a pairing. By a Lambert theorem, the series converges. The series converges. Okay, very good. And that's it. That was the question. Please take your time, look at it, and that's it. I think you have a couple minutes left if I got good memory. Okay, that's it. Take your time, look at it, and you should be okay. Okay? Good. Thank you, guys.